This led to a project that cybernetics had with the state of Virginia, and that was reinterpreting mixtures. What happened is that they looked at these new guidelines and they realized they had 375 reports or cases that they had were preparing reports on where what was okay under the old guidelines wasn't okay under the new guidelines. Instead of just removing all this evidence from the state, they elected to have it reinterpreted using validated computers. And the quotes indicate how people were thinking about mixtures, and still do often. District of Columbia's police crime lab, the director said mixture cases are their own little nightmare. It gets really tricky in a hurry. Dr. Peter Gill, who is a major DNA scientist, he still is, he was at the Forensic Science Service in England, which was their major national crime lab, said if you show 10 colleagues a mixture, you'll probably end up with 10 different answers. And the only problem with that is you might end up with 20 different answers. So I'm just skimming some results now from this Virginia study and just giving you some of the highlights. The reason for this is I'd like you to see what is it that scientists look for, or you might want to look for, in a validation study. One axis is sensitivity. If the person's in there, are you finding they're actually in there? Is it a sensitive method? If there's a true inclusion, are you going to detect it? And so the paper describes the reported matches, but the key result that I'd like you to look at is the range of answers. So these were 100 matches. Again, on the horizontal axis, this is the strength of match. 0 means the number 1. It's got no zeros after the 1. 24 is a trillion, 12 plus 12. The true amount of information is everything from basically nothing to single source style DNA if it wasn't a mixture at all. That's the actual amount of information, and that's the distribution. So TrueAllele is finding a broad range of information. We'll come back to that. Now, the other question, which is even more important in a criminal proceeding, is did you get the wrong answer? Is there a false positive? Did you falsely include somebody, and you're giving a match statistic against them in court, but they're really not in there? So to address this, we took the 100 matching genotypes and compared them against 10,000 random genotypes that did not contribute and asked what was the range of distribution. We did this for 3 different ethnic populations. And what we found is a lot of negative statistics. All the way on the right is 0. Anything to the right of that might suggest an inclusion, but the mass of these comparison numbers is out at negative 19. That's a match statistic that's 1 over a billion billion. It's very exclusionary. When people who were not contributors were compared with the evidence, they were excluded, and from the little bit that we looked at the tail, maybe 1 in 20,000 at a certain level, we could work out error rates. Error rates are good in science because they tell you with what accuracy you know your answer. The third major axis, in addition to sensitivity, if the person's in there, are you finding them? Specificity, if they're not in there, you're not finding, are you ruling them out? Is reproducibility. This was something that we saw with the NIST study. There wasn't a lot of reproducibility. So here, since we're using random algorithms to do probabilistic sampling statistically, we had the computer solve it twice, and then we looked at what the match statistics were. The x-axis is the first match statistic, the y is the second. Each of those points represents the result on the first computer run on the x-axis and the second computer run on the y-axis. If it were done in Photoshop, everything would line up perfectly on the 45-degree line. They're all equal. If the method is not that reproducible, you see a lot of scatter off in the corners. But the method is reproducible. There's this cloud that's lined up along the 45-degree line, and we can calculate statistically the degree of reproducibility. Now, this brings us to a comparison of methods, because once we'd established for this article sensitivity, specificity, reproducibility in this 5th published validation study, we then wanted to compare the methods. In fact, we didn't just want to compare the methods. The reviewers in the journal wanted to compare the methods. They said, you had all this data, what's going on? So we took their lead and we started doing comparisons. In the paper, there's a lot of statistical numbers given to these comparisons, which most of you would want to skip, but they're in there. scientifically. What do we see? The CPI method that we saw used originally in the Ralph Skundrich rape case is clustered around 6 zeros. The modified method that the FBI proposed 5 years ago is clustered around 2 zeros, a number around 100. And TrueAllele is giving a full range. So we commented on that and what that range means, but it turns out we can do even more than that. There are statistical tests for accuracy. And this was the first time anybody had looked at the accuracy of a mixture interpretation method. The idea is like this. If you're looking at just one number, you may not be able to tell exactly what it is. But if you're looking at 100 numbers, and you have more information about how DNA match statistics behave, which I won't go into right now, it's in the paper, then what you would expect is an even distribution of those match statistics on this powers of 10 scale if your data have evenly distributed and pretty much random compositions, which they did, as described in the paper. So what we expect is what we saw with TrueAllele, and statistically, we see a broad distribution from 0 up to 24 that statistically isn't different from just a flat line, a uniform distribution. That's at least evidence that it's not inaccurate. However, with the human review methods, it's clustering, and that's support for the concept that maybe it isn't accurate in that same sense. We also did correlation. Now that we had determined that we were accurately measuring information, we wanted to compare what these statistics were measuring, CPI, the inclusion method, and the modified higher threshold method in red, with this information method, with TrueAllele. And just quoting from the paper, basically we didn't see much of a correlation. You know, in science, if you have an R-squared value, that is how much of the variance is unexplained, and the R-squared is 0.9 or 0.95, that's explaining a lot. In social sciences, that number might drop down to 0.6, 0.7, even down to 0.5. That is 50%. When over 90% of the variance is unexplained, whatever these, and it's happened for both methods of thresholds at the human review, whatever it's measuring, it doesn't seem to be identification information, which is interesting because I think there's like 100,000 match statistics reported in the country using these inclusion methods, and whatever they're reporting, it doesn't seem to correlate with identification information, which is something that's of interest maybe to a trier of fact. We also addressed the question of, doesn't TrueAllele just always give bigger numbers? No, that isn't what it does. There were 5 matches where the TrueAllele statistic was lower, but more interestingly, there were 10 comparisons with a negative number where TrueAllele was suggesting an exclusion, where the CPI method, 5 of those gave an inclusionary number, and even moving to the higher thresholds was still including at the level of 1 million that subsequent examination of the data suggested these were not true inclusions. So there's an error rate associated with inclusion methods. We ended up writing 72 case reports. 10 of them from this study went to trial. There have been other trials. I testified in 8 of them. The ones indicated in brown were testified to by an analyst who now using TrueAllele. Virginia brought TrueAllele online. They used it for the complex mixtures. And so we saw in federal, the military court was a Marines court-martial, and a lot of county courts on a wide variety of charges that TrueAllele had an impact on criminal justice by not just throwing out the reports, but by reworking these samples.